time for the last section, chapter 6, 6.9. We're going to be looking at building exponential and log functions from data. So we're going to actually do exponential regressions and log regressions like we did back in chapter 4 with our linear and quadratic regressions. So here's an example. It says your rich uncle left you some cash in a mutual fund that will mature in 10 years. Only if you can create an exponential function that matches the data provided. The function must be in the form of a equals p times e to the rt power. How much is the mutual fund worth if it matures in 10 years? So what we're going to have to do is we're going to have to put this in L1 and L2 of your calculator. There's my screenshot. And again, I'll walk you through the steps on how to enter this on the calculator if you have the new one. This is the older one. Again, my diagnostics have been turned on in the calculator. We are going to do an exponential regression. So we're going to go stat, calc, and we're going to choose 0. So we've got to scroll down until you find EXP REG, exponential regression. All right, so L1 and L2, those are your displays. That should be defaulted. Go ahead and crunch out the numbers, calculate it. And don't forget, if you wanted to see the graph, you can go ahead and save it in Y1. But we just need to come up with a function, put 10 in for t, and come up with our answer. Now, the crazy thing about this exponential regression is that the base raised to the x power is not base e. What the calculator does is it calculates the best base for the data values. So we have to take what's given and convert it into this. Now, the other thing you should notice is we have a very, very strong correlation. So your points are right on the mark for being exponential. So here is my equation, and it looks a little strange because your beginning balance was $20,000, but the calculator says based on the data values, this is your best beginning balance using this base value right here. All right, so what we're going to do is we're going to convert this into a equals p times e to the rt power. So we're going to flat out call p that value a from the calculator. We're going to let the e to the rt power be equal to this 1.08556777777 raised to the x power. So since the t and the x are representing the same variable, only the x just came from the calculator, e to the r equals this long decimal value. All right, well, what we can do is what we did earlier, use the power rule to move the t to the outside. Now you can see e to the r equals that value. So we're going to convert it into a natural log. So r is going to equal the natural log of that huge decimal. Well, we go to the calculator, and we just go back to the home screen, type this all in, all the decimals, and your r value is going to be really long, but we'll just take it to 4 decimal places like the book or my math lab will ask us to do. So we'll put this as 0.0821 times t with your p being multiplied to e. And again, we already declared what p was, so here's my function's equation. All right, so we did it. So now we get to find out how much this mutual fund is worth in 10 years. We'll put the 10 in for t. Calculator says it's going to be worth $45,047.31. And who says math doesn't pay off? Okay, bad joke. All right, and our next regression we said is going to be a log regression. So again, here's the data. Plug this into L1 and L2. We're going to build a log function in this format, a plus b times ln of x. And then what we're going to do is we're going to find how many computers were supplied when the cost was $1,650. That would be your x. So again, enter the data, all in. We're going to go a linear regression, a natural log regression. We're going to look for capital L N capital R E G. So stat, calc, and it was right next to that exponential regression. So choose number 9. We're going to store this one in Y1 because we're going to make some graphs of it. And again, I'll demonstrate that again in the newer calculators. This is the older one. This too has a very strong correlation coefficient. So the A value is a negative 449.276177373. The B being multiplied to your natural log is 81.6980. But of course, we'll round these to wherever they tell us to. So if they say 4 decimal places, we'll round them to 4 decimal places. So here's my equation. And so how many computers were supplied at the cost of $1,650? That's your X. You can put it in right there. So we could crunch this on the home screen, or we can go to your calculator and find it there. So 2 ways we can type it in. 1650, store it for X, and I think we have to go Y1 parentheses X, and then it'll automatically store it. And you can see the 2 values here are slightly different because we did round this to 4 decimal places. So our value is slightly off once you get to past the 3rd decimal place, which is logical because it said round to 4. So yeah, we should see after 4 decimal places we're going to be off. So you can type it straight in, but if you store it, you can also store for X or use your Y1 feature to crunch the values. And again, I'll demonstrate that with our calculator here. All right, so I'm going to grab the calculator here. Now I've got my data in L1, L2, 3, and 4, so bear with me here. So if we do that exponential one, stat, calc, scroll down to 0, that's where the exponential regression is. Remember, in the newer calculator, give a pop-up window, there's L1 and L2. If you want to store the regression, it's alpha trace, put it into Y1. If you want pictures of it, or if you want to do some number crunching, calculate it. There's my formula again. That's from your uncle. Again, strong correlation. The last one, let me clear the screen. Stat, calc, number 9. But now my data I had in L3 and L4. So if I want to change that, it's second number 3. Enter, and then we'll go second L4. Again, whoops, passed it up. I want to store that in Y1 just to show you the feature I was doing with the older calculator. We'll calculate it. There's my answer. All right, so 1650, you can literally go, because it's automatically stored in Y1. In the home screen, you can go alpha, trace, Y1, enter, left parentheses, excuse me, $1,650, and it gives you the value. Excuse me. So 156 computers is what we're going to have. All right.